going to use the integration, but integration by parts will be used here. Whenever you're going to use integration by parts, if you have u, d, v kind of format, that would be equal to u, v minus v, d, u integral. That's the formula. So one of the, in the question, for example, in the first one, there are two functions, right? One function will be named as u, one function will be named as dv. How do you decide that? Is usually by a small mnemonic. I use LI8. It's used a lot in the books. L stands for log functions. I stands for inverse functions. A stands for algebraic functions. T stands for trig functions. E stands for exponential functions. Now, when you notice, the first function is just an algebraic function. The second function is trig function. In this list, algebraic function comes first and trig comes after. So whoever comes first, we name that as u, and whoever comes next, we connect it with dx and make it dv. So basically, let's write it down. U is equal to x and dv is equal to sine 10x dx. Okay. So for u, you need to find du. That would be the derivative of x, which is 1 times dx, the differential. For dv, though, you need to integrate to get v. So when you integrate it on both sides, the integral of sine is negative cosine 10x by 10, right? So let's say this formula is integral of u dv is uv minus integral v du. So let's look at u, v, multiply these two and write it here. So x times negative cosine 10x, negative right here, by 10, minus integral of v. V is this one. So negative, 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 make it positive, cosine 10x by 10 times du. Du is just 1 dx. Okay. So this is negative x cosine 10x by 10 plus this 1 by 10 I can just write outside because that is the constant. So 1 by 10, the integral of cosine 10x is sine 10x by 10 plus c. So your final answer, negative x cosine 10x by 10 plus sine 10x by 100 plus c. That is your answer of the integrals. Let's work on the next one. Part B. T here is an algebraic function. E is exponential function. Algebraic function comes first, therefore u is named as t, and dv connected with the next function is e to t dt. We are going to differentiate u to get 1 dt, and we are going to integrate dv to get v is equal to e2 dt by 2. Okay, so if this is u dv's integral, that would be uv minus integral v du. What is u? Times v. So we have t times e2t by 2 minus integral v e2t by 2. I can write 2 outside. Du. Du is dt. T e2t by 2 minus half. Integral of e2t is e2t by 2 plus c. So your final answer, e2t by 2 minus e2t by 4. C. The first function is algebraic function. The second function is log function, right? Log function comes first. That means u is equal to natural log of x. The remaining function with dx attached is dv is x cube dx. For u, we need to differentiate. Du would be 1 by x dx. And to dv, we need to integrate. V is equal to x to the power 4 by 4. So our formula is integral of u dv is equal to uv minus integral of v du. uv x4 by 4 times natural log of x minus integral v. V is x4 by 4 times du is 1 by x dx. Okay. x4 natural log of x by 4 minus, this can cancel, is x cube. So integration 1 by 4 can pull out x cube. x4 natural log of x by 4 minus 1 by 4 times x4 by 4 plus c. This 4 times 4 can be written as 16 here. Everything else is good. This is your answer. In this question, the first part is exponential function, second is trig. The trig function comes before and exponential comes after, therefore trig function would be u, cosine 2x. And the remaining function attached with dx, which is ex dx, would become dv. U we are gonna differentiate. What is the derivative of cosine 2x? Negative sine 2x times 2 dx. dv we are going to integral, so v is equal to ex. Okay, so if we use the formula, integral of u dv is equal to uv minus integral v du. What is u here? Cosine 2x times v is ex minus integral of v ex times du is negative 2. Negative 2 is going to come out and make it positive, sine 2x dx. Now, what is special about this function is we again got two functions. So we have to work on integration by parts one more time, okay? So for one more time, again, we have to see this is an exponential function, this is a trig function. Trig function comes first, but now I'm going to use u as sine 2x, okay? And v with ex with dx together is dv, which is ex dx. So we are starting the whole process again. Differentiate u, du is equal to cosine 2x times 2. Integrate dv, you will get v equal to ex. So let's write again using this formula. The first part is already done. Don't change anything to that. Ex cosine 2x plus 2. Now this has to be expanded using the uv formula again. uv. So ex sine 2x minus integral v du. Ex du is 2 cosine 2x. So 2 comes out, cosine 2x dx. If you guys notice, I started from ex2x, ex cosine 2x, right? That is, now I'm back here. So this is like a circle. I'm coming back to the problem. So what I'm going to do is I'm going to start with naming the initial function I. So I is equal to ex cosine 2x plus 2ex sine 2x minus 2 times 2, 4. This whole thing is named as I, right? This is where I started from. Now I have 4i here, I here. I'm going to take 4i on the other side. I plus 4i is equal to ex cosine 2x plus 2ex sine 2. So I plus 5i is equal to 5i. I need to find I. So I'm going to have to divide by 5 on both sides. Ex cosine 2x plus 2ex sine 2x. We have the answer as ex can be factored out, 5 is outside. Cosine 2x plus 2 sine 2x. That is your answer. One thing you remember, when you're completely done with the question, always add a c to it because it's an indefinite integral, so you have to add a c. Let's work on the last part of the problem. We have z cube ez. There was a dx written, that's a typo, dz here. So this function is algebraic, this function is exponential. Algebraic comes first, so that is u. Exponential attached with dz is v. So u is equal to z cube, dv is equal to ez dz. Differentiate u, we get 3z square dz. Integrate dv, we get ez. Okay. Now the formula is, we know, either using this u times v. So z cube ez minus integral v du ez times 3z squared. 3 can be pulled out, dz. Okay. Now you guys see this is a cyclic problem again. Again, we came up with another problem which has to be dealt with the integration by part. So we're going to start again. Again, this is algebraic. So u is equal to z square and dv is equal to ez dz. Similar steps. Du is equal to 2z dz, and integrating we get v is equal to ez. So let's expand it again. Z cube ez minus 3 times, this can be opened as uv z square ez minus integral v du. 2 comes out, z. So when I open the parenthesis, z cube ez minus 3 multiplies inside 3z square ez, negative negative plus 6 integral ez z dz. And we notice again we have two functions, integration by parts applied. So again, u is equal to z, dv is equal to ez dz. Using the similar argument, du is equal to dz now because the derivative of z is 1. And if I do integral here, v is equal to ez. So let's write that. Don't change anything about the first two terms, they are same. Z cube ez minus 3z square ez plus 6 v uv z ez minus integral v du. V is ez, du now is 1, so that's just dz. We are finally able to write the final answer. Z cube ez minus 3z square ez plus 6 z ez minus 6 integral of ez is just ez plus c. So this is your final answer of the integral.